Now, probably the story of Kasparov and Deep Blue has told you that this is not just about little cute demonstrations of how our visual system sometimes is wrong or how our visual system sort of interprets the world in order to adjust for its own limitations. And the idea of computational complexity permeates every aspect of our mind. Let me give you two last examples. Say that I were to tell you this. In fact, what if I asked you this? Why did Gabriela drive to the restaurant? What's your answer? Chances are your answer sounds something like she was hungry. Like you understand this question as asking you, why did she want to eat? And my guess is that most proficient speakers of English, that's the first thing that occurred to you. What if I asked you this? Why did Nia roller skate to the restaurant? It's immediate that your answer now is not because she was hungry. Your answer now is because she likes roller skating, or because her car broke down, or because she wanted to be active. I don't know. But it's very clear that even though these two sentences are virtually identical, what you understand out of them is completely different. And again, you didn't effortlessly think about this. It's just your gut reaction. Your mind just automatically read these two sentences. Faced with the fact that these two sentences can have several different meanings. I mean, look, even in the first one, it's unclear. You spontaneously thought that I'm asking you about why she went to the restaurant, but maybe here too, the question was, well, why did she drive? She could have walked. But that's just not what came to mind, right? You read the first sentence and you heard, this is a question about why she went to the restaurant. Then you heard the second question and you thought, this is a question about why did she choose that means of transportation? But honestly, that could also have been true of the first sentence. By the same token, the second sentence, it's totally legit to answer, well, because she's hungry. It's just not what came to mind to you. Again, faced with a possible multitude of interpretations of that sentence, somehow your mind has an automatic, guiding principle that says, okay, in the first one, what you're asking me about is why is she going to the restaurant? But in the second one, what you're asking me about is about the means of transportation that she chose to go to the restaurant. See, language is actually very underspecified in many ways. It's very ambiguous. And yet, we have very little difficulty understanding each other. Let me give you my favorite example. See that I were to, say we were in class, and I show up, and the first thing I do is I look up and I say, it rains. What do you think? What came to mind? Well, you probably thought is, well, if you step outside of the building, it'll be raining, right? This is probably the spontaneous interpretation that came to mind when you heard me say, it rains. Why? I mean, it doesn't get more underspecified than it rains. Why did you think that I was talking about outside the building? Why didn't you think that I'm talking about nearby where I live? Why didn't you think that I'm talking about in the Himalayas? It's raining there right now. Why didn't you think that it's raining in Italy? I could have been talking about any of these things. Totally plausible, totally legit. It's a totally good interpretation of the sentence, it rains. It's just not what came to mind. It's just not what your mind thought. Your mind read it rains and automatically went to a certain interpretation. Again, computational complexity. There are possible infinity of interpretation of the sentence, it rains. It doesn't get more underspecified and more ambiguous than it rains. And yet, despite the computational complexity of interpreting that sentence, it didn't take you a heartbeat to know that I meant, or at least to think that I meant, it rains out here. So computational complexity affects all aspects of our mind. And here's the last one, learning. Picture this scenario. Mother is somewhere outside with her young child. She sees an animal in the field, points at it in the distance, and says, rabbit. Now put yourself in the shoes of the little child. How on earth are you supposed to know what she's talking about? I mean, she's pointing towards that thing, but what does rabbit refer to? I mean, is rabbit a property of the object? I don't know, its color or the fact that it has fur? Is rabbit the action that that object is doing? Maybe it's hopping, maybe it's moving its nose in a very cute way. Is that what she's talking about? Or maybe it's a proper name. Maybe it's Mr. Rabbit. Or maybe it's a role. Maybe a pet. Maybe that's what we're talking about. Or maybe it's the category of that object. That it's an animal. Maybe it's not even about that object. Maybe it's about, I don't know, the interaction of that object and the environment it's in. How'd you know? How is the child, how possibly could the child, faced with so much ambiguity, there's so many possibilities, how could the child possibly know or figure out that the mother is actually talking about the object as a whole? And yet, again, faced with such a computational complexity, faced with so much ambiguity and so many possible interpretations of what's happening, and again, what is a very underspecified problem. I mean, the alternative is to be paralyzed and to just not know what to do with the word rabbit. And yet, every single one of you, everyone who's a proficient speaker of English, knows that rabbit refers to the whole object. Turns out, we just all grow up to understand well the association between sounds and objects with very little ambiguity. And we're going to discuss this in detail a few lectures down the line. But this too just seems to relate to a spontaneous guiding principle, a spontaneous bias that our minds have in order to cope with this type of computational complexity. It just so happens that when learning words, our minds seem to have a bias towards assuming that a new label refers to the whole object and not to one of its attributes, components, the stuff that it's doing, or the interaction between the object and the environment. It could have been different, but that's what our minds have evolved to do. Again, massively computationally complex situation, as I said, potentially paralyzing. The number of alternatives of what the mother, means, given the word, given the pointing and rabbit, I mean, it's paralyzing. And yet, we just all grew up to understand that. Once again, this is an example of how our minds have evolved guiding principles, have evolved biases to face computational complexity.